Hello everyone, today we're taking a look at modeling problems, trigonometric modeling problems. These are primarily IB questions for both HL and SL students. This is a sort of thing that might appear on either test, and it's kind of a level of difficulty where you could get it on either. It would be a more challenging problem on SL, an easier problem on higher level, but relevant to both, and a thing that I find a lot of people have trouble with. So we're going to be going through how to approach these problems and how to solve this particular problem today. There are other videos on a playlist that I'm going to make, also covering other questions on here. So if you need help with this and you find this video helpful, you can also find others. But we'll just dive into solving and looking at this problem. So Singapore Flyer is a giant observation wheel in Singapore with a diameter of 150 meters. The wheel rotates at a constant speed and completes one rotation in 32 minutes. The bottom of the wheel is d meters above the ground, and they've kind of hidden this a little bit, but it's quite important. Oh, that's a highlighter. It says the seat starts at the bottom of the wheel. Okay, so that, I imagine, is going to be helpful. These kind of Ferris wheel problems are super common. We've not gotten yet into the actual trig modeling part, but we can see down here that it's going to be a cosine function. I always draw just a basic version of the function, normally for a period. So cosine starts at 1, comes down, and comes back up. This is a 1 period rotation, which you can tell because we are starting and finishing at the same point, having gone through the minimum. So this is going to be 2 pi, because cosine repeats every 360 degrees or every 2 pi radians. That means this point down here, dead in the middle, is pi comma minus 1, and our endpoints are 2 pi comma 1, and this would be 0 comma 1. And then our intersection points here and here are going to be pi over 2 comma 0, and this is going to be 3 pi over 2, also comma 0. So this is just kind of to give us something to work off of when we're adapting various things, or to keep in our mind an idea of what the function looks like. I'm a big believer that before the test you should be able to produce this from memory fairly quickly. I think that will help you, even if it's not relevant to a problem. Just knowing this is super useful. So the question says, the first part, after 16 minutes the seat is 165 meters above the ground. Find d. Okay, so 16 minutes is kind of a specific number. How is this really supposed to help us find d? Well, certainly if the Ferris wheel is 150 meters across, if we were starting exactly on the ground, like there was no gap between us and the ground at the beginning, you would expect that at the very top we would be 150 meters above the ground. So clearly this is kind of, d is adding on top of the 150 to give us a bit more height. How do we know for certain that it's going to be at the maximum, right? Because you might imagine if d is very large, it's possible that we are positioned here at 150 meters, plus, like the diagonal would be here, but we've got so much clearance at the bottom we could still be 165 meters off the ground. That's probably not the case, because we start at the bottom. I mean, this was immediately relevant. So we start at the bottom, and the full rotation takes 32 minutes. 16 is half of 32. That means we have risen all the way to the top at the very point that we're at 16 meters. So what does that tell us? It tells us that we are directly 150 meters above the base of the Ferris wheel, and that therefore d is going to be an additional 15 meters. So d is 15. D is 15. Okay. After t minutes, the height of the seat above the ground is provided by this function. Okay, great. We've now got our trig function. Find the value of a. So each of these values is a transformation that's been applied to our base function. So our base function is the y equals cosine. I guess I did cosine x, but it would be cosine t in this case. We're transforming that function to get it to fit the framework that we're looking at, right? So the plus 90 here, that's a vertical shift because it's outside of the cosine and it's added on, right? So we're just moving up by 90 degrees. You'd assume that puts us right at the midpoint. The pi over 16t, this tells us the period, right? How long it takes us to go one full rotation. It's going to affect that because it is scaling horizontally our values, right? So it's pressing them together or it's stretching them further apart. A, which is what we're interested in, is a vertical stretch. So this is going to determine basically the vertical distance between our maximum and our minimum values. Now on the base cosine function, that vertical distance in total is 2, and then the amplitude would be 1, right? So that's the distance from the center line to the very maximum or to the very minimum. In order for this to work with the Ferris wheel, we want that distance between our maximum and our minimum values to be 150, because that's how much your height is changing literally on the Ferris wheel between your minimum and your maximum. So how do we get that? Well, we need to multiply 2 by a to get to 150, which would make a 75. Or alternatively, you could think in terms of amplitude, and we could say 1a is going to be equal to half of the total distance of our Ferris wheel, because that's basically the radius of our Ferris wheel in this case would be 75. And then if we rearrange it, we get, again, a equal to 75. So that's going to be our answer. Find when the seat is 60 meters above the ground for a third time. Okay, so let's sort of break down and break apart this problem. We're basically being given a y value, 60 meters, or a h value, I suppose. I mean y in the sense of the subject of the function. So probably the simplest starting point is just to go, what does that look like, right? If we plug 60 into our function, I'm going to erase some of this so we can see it clearly. Yeah, plus a cosine pi over 16t. So I subtract 90 from both sides, that is negative 30. This is equivalent to a cosine pi over 16t. And we said that this here would be 75, right? So we actually do have this value. So again, to try and simplify this, I'm going to move this over and divide it. So we get kind of negative 30 over 75. This will simplify because they can both divide by, they can both divide by 15, but the simplest for me is to take 3 out, because then it's 10 over 25. We take 5 out, negative 2/5. So that is going to be equal to cosine of pi over 16t. Now, this is relatively easy to solve if we've got a calculator. We can just plug this into our calculator and get a solution, which is what we're going to do. But we have to, this question is more about just finding the value for t. We're also trying to figure out a series of values of t that will get us our solution so that we can pick out the third one, because it's going to keep happening that we can be at this negative 2/5 value. So I'm just going to go and figure out what that is. So in a calculator, we'll put in arc cosine, negative 2/5. I am getting this value in degrees, but I want it in radians, and I'm getting 1.9823. But I'm going to call it 1.98. So that's 3 significant figures. 1.98 is our arc cosine of negative 2/5. I'll write that out. Arc cosine negative 2/5. We're doing the cosine minus 1 function probably in your calculator. Now, that's not the value for time. That's the value for 16, like pi over 16t. But for our purposes, and this is my personal preference, I like to find multiple solutions of this first, and then we can go ahead and adapt them to get them into terms of t. The reason I want to do that is when we do things like add 2 pi to get other solutions, a very common mistake is that people will apply that period to the value of t when it really should apply to the angle as a whole. So it's at this level, the arc cosine level, that we want to find our other solutions, in my opinion. Now, with cosine, we have a period of 2 pi. That means I can add 2 pi to get multiple solutions to my problem. So we'll do that first. I'm just going to add, a couple, because we're not going to need very many. So first we get 8.227. And then if I go again, I get 14.55. I know we sort of stepped out of 3 sig figs here, but that's fine. When we get to the answer, we'll put it in correct formatting. It's just 2 decimal places is okay. The thing we have to be careful of here, because our answer is not the 14.55 value. The thing we have to be careful of here is, for sine and cosine, in addition to being able to add 2 pi r period to get other values, we have an alternative solution that will also repeat every 360 degrees. For cosine, that is the negative version of our answer. So that is negative 1.98. This will also repeat every 2 pi. So if we add in negative 1.98 and then we go in and get these other solutions, first I'll add one set of 2 pi, that is 4.30. And then we go in again with another 2 pi, that is 10.58. Okay, the reason this matters, if we're going from the very beginning and we're looking for our third solution, our third positive solution, presumably, our very first solution is the 1.98, but our second solution is going to be the 4.3, and then our third solution is this one, the 8.27. But obviously this is not our ultimate solution. This is the value for the angle that cosine needs. So to find our actual solution, we're going to set this equivalent to pi over 16t, and then we're going to solve it as 16 over pi times 8.27 equals t, and put that to 3 significant figures. 16 over pi, 8.27. So I'm getting, this is 42.11. So 42.11, which to 3 significant figures would just be 42.1. And that ought to be our value for the time when the seat is above the ground at 60 meters for the third time. So I'm just going to go through, I kind of haven't really checked my work at any point, so this is a good opportunity before we finish the problem to make sure I've not made any blindingly obvious mistakes. So I'm quite confident about the first part. Halfway through 32 minutes is 16 meters. We're starting at the bottom. The wheel is 150 meters, so if we add 15 on, that makes sense. This next part, at t minutes, the height of the seat is given by this function. Find the value of A. A is our half of 150 is 75. That should match our amplitude for our function. So 75 makes a lot of sense here. I'm confident of that. And then finally, we need to look back over this. So 60 equals 90 plus A cosine pi over 16t. Make sure I've copied that down correctly. Yeah. A was 75. Okay, we minus 90 from 60. That does give us negative 30. Negative 30 divided by 75. Take away 3. Yes. Take away 5. Yes. Go get it in the calculator. Yes. I think this is all valid. Okay. So we have our solutions there. This is how I would approach the problem. If you're having a hard time with this type of problem, there are going to be 2 other videos on it. So I don't know if you've seen the first one, but there's a playlist. It should have, at this point, 3 videos. If not, those are coming out. And yeah, I would check those out.